guys to do before we really get into it is I want you to think about some things involving these systems. So I want you to turn your paper to the back. You're going to do a little bit of a quick write explore activity for me. And so I want you to think about how you can answer some of these questions. So you're going to do this on your own or with your group, but I want you to think about these. So it says, given a linear quadratic system of equations, answer the following questions. So first you're going to tell me, what would the shape look like of the graph of the quadratic function? So what would that shape look like? What would the shape of the graph of a linear function look like? Thinking about those two shapes, what are the possible number of solutions that you could have for that system? So if you think about those two shapes and how you would graph them, what are your possible solutions? And what would each of these solutions look like on a graph? So it doesn't have to be perfect. I didn't give you a specific one, but what could maybe they look like? So I want you to show the different possible solutions and how they could look on a graph. Okay, so I want you to think about that.
What is the possible number of solutions? Solutions. I know quadratic has two.
Okay, think about when we did just did the system of lines, right? Where did we say you would find the solution on the graph? So if you were looking for the solution of two lines and you wanted to know where they were equal, where would you look?
Where they intersect.
The intersection, okay. So go from there. So talk with your group.
You literally buy an entire village.
What's going on over here?
I'm never secure.
I just have a question on the.
So you guys all agree on this?
Well, yeah, we have the same thing.
Okay.
But like, I think this is right for the linear function because it's two lines with an intersecting point. You put an arrow.
Okay, so
But what if
this,
it intersects at one of the graph points? Like, you know,
okay, so this is two lines, right?
Yes, for like the two.
Okay, so that was a system of a linear and a linear, right? So if you have a system of a quadratic and a linear and you told me what those look like, how would they look as a system?
So it would be like
A parabola with a line through it?
Maybe.
it's a possibility.
something about it.
I think you're trying to get too technical with your drawing.
Yeah.
So what did you just say, Morgan?
I said like this with like a line going through it.
So like half the rabbit.
Okay. So then if it was a parabola with a line through it, how many solutions would you have?
One.
A lot?
Just one.
Maybe depends on where the
Or I mean,
parabola
two
is
solutions
located.
to make the intersect, right?
What was that,
Two
Jaden?
solutions to make the intersecting point.
Well, no, it depends
Okay.
because if the parabola goes through
See.
there, what if the line went through here? Have be 1, 2, 3, 4.
Careful, this is just your axis. That's not your line. Like your x-axis and your y-axis, those don't count as your graph.
Okay.
So then now looking at it,
Oh, just 2 then?
okay. Could there be any other ways that you could arrange those to get a different number of solutions? Did you guys hear my question?
Yeah.
Could you rearrange them differently to get a different number of solutions?
I feel like you could.
Well, what
Try.
if the line
You
went
do like
through?
that, and you go, there's two solutions. Like that.
Or what if?
Okay, but that's still two solutions. It's two different solutions, but it's still two. So could you get a different number of solutions by arranging it any other way?
It's still gonna be the same.
What if, Ms. Van Tassel, what if it only went through 1 point?
Okay. What if it only went through 1 point? So where would it be if it only went through 1 point? Because here this line keeps going, right? So that would still intersect two places. Could you rearrange it so that it does only touch 1 point?
what? What do you mean rearranging it? You can just
Like-
take it and shift it?
Well, we don't have an actual system, so any parabola and any line, like could you move them in different places?
I mean, what if it was like... Would that be only one for the rest of it?
You're on the right track. You're on the right track. I'm just going to kind of call on some people. So what is the shape of the graph of a quadratic function? So let's see, Jaden. What is the shape?
I said a parabola.
Okay, a parabola. Do we agree? Parabola?
Yes.
Okay. What is the shape of the graph of a linear function? So Caitlin, what is the shape of the graph of a linear function? Line. Do we agree? Yeah. And so what are the possible number of solutions to a quadratic linear system? So I want to hear what some of you got as answers for that. So just raise your hand. Who can tell me one answer that you got for the possible number of solutions? Faye? Two. Okay, maybe. I don't know. We'll talk about it. Let's see. Jade. Okay, maybe. I don't know yet. We'll see. Did anybody get anything different? Cameron? Okay, 0. Okay. Anything different? Higher than 2? No? Nothing higher than 2? Okay. All right, so let's talk about it. What would each of those solutions look like on a graph? So who can tell me for 2 solutions, what would the parabola and the line look like? So let's see. I'm just going to call on somebody. Tommy. What would the graph look like for a parabola and a line to have 2 solutions?
Not even close to that, right?
Oh,
Not
I didn't get the line.
Okay, but just think about it. So a parabola and a line. How would you draw them so that you have 2 solutions to your system?
I draw the parabola.
Let's see.
That's the parabola.
Okay. So Tommy's picture looks like this. What do you guys think? Yeah? Is that 2 solutions? Where would the solutions be? Okay, where they intersect. Can I get someone else to come up and draw for me what one solution would look like? So I'm going to pick somebody. So I know that you guys are eager to share. But let's see, Grace. Can you go up there and draw for me what one solution would look like? Oh, that's a good, sounds good to me. All right. What do you guys think? One solution? All right, so I'm going to bring back to geometry. So thinking about geometry and like maybe a circle and what you call that line that just kind of brushes it. What did we call that line from geometry? Do you remember? Is that what you were going to say? What did you say, Grace? Tangent. So a tangent line, right? That would give us 1 point. What did we call this line with a circle that kind of went through 2 places? Anyone remember? You're so close. It does start with an S. Say that again, Grace. Secant line, right? So we deal with secant and tangent lines even when we're not dealing with circles. Okay. What about the third one? What would no solutions look like? So let's see. Ash. I want you to go up and draw no solutions for me. What could that possibly look like? All right, perfect. What do you guys think? Is that no solution? Why is it no solution? Yeah, it doesn't intersect, right? So no solution there. All right, what I want you guys to do from here. What's the matter?
I'm just looking at this paper.
Don't look, work with him. Maybe that's part of the problem. Jaden, are you talking to him when you're doing it?
Yeah, I know what he's doing.
You know what he's
I'm
doing?
just not copying.
Can you tell me what he's doing?
Like step by step what he did?
Yeah.
Okay. Well, first he tried doing this. He solved for y on this equation,
Okay.
and when he got it, he went to plug it back in, and it didn't work. We ended up with this.
Why didn't it work?
I plugged it into the wrong one. I plugged it into
Oh, okay.
So then he took what he got over here. He took this formula and plugged it into this, and that went here, and then he just started solving it from there, and ended up with like having to distribute, and that's where I got lost, like right here.
Right here. So
he
it
just
looks
started-
like from here to here you got lost, or
No,
so you're good with what happened here?
kind of. Like when he had to square, or he had to distribute all that and had an exponent, I just
And he
thought-
didn't show his work, so that like threw you
No,
off a
he
little bit.
did.
Okay.
Well, I just didn't understand why.
So
I
think
feel
about
Like he missed something, so I just don't
think about x plus y squared. What does it mean to square something?
You multiply by itself.
Okay, so how could I rewrite x plus 5 squared? Just rewriting it. Not actually, don't distribute that squared, but how could I rewrite something squared? Do you see it now?
Yeah.
So usually when students see it that way, they see it quicker than this way. But you guys need to start recognizing this.
But that's what I did.
What?
Yeah, I know what that is.
Okay. But did you see that from here? You did? Okay. And then he did that, and then he ended up with, so how did he go from
I
here
don't
to
know. I
here?
don't know. He squared it. He squared
Right.
this whole thing.
Okay.
went there.
And he got x squared plus 10x plus 25. But then how did he end up with 2x
Multiplied it
squared?
by 2 because
Okay.
you had to distribute that.
So you know what he did?
Yeah, but I probably couldn't do that on my own.
You could.
'Cause this
What do you
part,
mean?
I don't know what he's supposed to do with this.
You just walked me through somebody else's work.
But I don't know what he does with this part now. Like,